All right, guys, yesterday we saw systems of equations graphically. Now we're going to solve them algebraically. That's one of my favorite words. I mean, look at that word right there. Are you kidding me? That's huge. I don't know why they have to add 6 letters to make algebra become an adverb. Maybe somebody can tell me that later. All right, 2 ways to do these. The first way is my favorite way. I shouldn't have said that. Called elimination. And basically what you're trying to do is make one of these variables somewhere, either one of the x's or the y's, go away. And you do that by multiplying both equations all the way through by the same number. So I'm looking at the x's right now, like I got a 5 and a 10. So what I'm going to do is I'm going to try to make that 5x right there become a negative 10x so I can add it to the positive 10x. So I'm going to do this. I'm going to bring the first equation over without changing anything. Now the second equation, what I'm going to do, because I need that 5 to become negative 10, is I'm multiplying the whole thing by negative 2, both sides. So if I do 5 times negative 2, 3 times negative 2, and negative 12 times negative 2, that's what I get. Now that equation right there, because I multiplied the whole thing by 2, is equivalent to the equation over there. So all I did was change the numbers, but it's really the exact same equation. So that's all legal. As long as you remember the rule. You can do whatever you want to one side of the equation as long as you do the same thing to the other. You must do the same thing to both sides, which is what I just did, by the way. Okay, so I'm going to add the equations together. When I do that, those are gone. I get negative 8y. And over here, if I add that, I get 40. Divide by the negative 8, I get negative 5. Now, that's my y. Now, for my answer, I need the x and the y coordinate. I need an ordered pair. So I got to take that y, that negative 5, and plug it in one of those 2 equations. It doesn't matter which one you pick. The numbers on the bottom are a little bit lower, so I'm going to pick that one. So I got 5x. If I put the negative 5 in for that y, that becomes negative 15 equals negative 12. If I move that negative 15 over, that becomes 3. So divided by 5, I get 3/5 for the x, and my answer would be 3/5 for the x, negative 5 for the y. And we solved it. It should also work in that top one. If I'm taking a second right here and plugging it in my head. Yeah, it looks good. So perfect. Second method is called substitution. I only want you to ever do substitution if you can find a variable in the equation that has 1 as a coefficient. And what I'm seeing right now is that x right there has a 1. It's 1x as a coefficient. So what you need to do is solve for that variable. So I'm going to say x equals, I'm moving that 3y over to the other side like this. Okay, that's what x equals. That's going to be a big deal in a minute. So don't forget that's there. X equals 3 minus 3y. It's called substitution because I'm going to take what x equals in that equation and substitute it into the other one. Okay, so where that x is in my top equation, instead of the x, I'm going to put 3 minus 3y. I'm going to put a plus 5y and a negative 5. All right, and I'm just going to solve that now. So I'm going to distribute the 2. Still have the 5y. Still got the negative 5. I'm going to do 2 things at once here because this is algebra 2. I'm going to add the y's together. That's negative y. I'm also going to take the 6 over to the other side, which makes it a minus 6, which gives me negative 11, which means y is actually positive 11. So there's my y. And again, to get the x, I got to plug it in. But here's the good news with substitution. I'm going to plug it right there because it tells me what x equals. X is 3 minus 3y. Well, y is 11. Okay, so that gives me 3 minus 33 for my x, which means my x is negative 30. So my solution there is negative 30 and 11. I'm kind of plugging that back in my head. Yeah, it looks good. All right, one more slide. There are special cases, just like there were when we graphed, like parallel lines or the same line when we graphed them. There's also special cases when you're solving them algebraically. So what I'm going to do, I'm looking at that 8 right there. I like it. So I'm going to take that top equation and multiply it by negative 2, the whole thing, because that will give me a negative 8. But look what happens when I do that. It gives me negative 8x plus 6y and negative 20. The bottom equation, look what the bottom equation is. Are you kidding? So what happens is if I start to add those, everything goes away, which gives me 0 equals 0. Now here's the weird thing. What you got to do is you got to ask yourself, does 0 equal 0? Is that true? And the answer is yes, it's true. So that means there's infinite solutions. Remember, not all reals, infinite solutions because they're ordered pairs. Okay, instead of, you can't just plug in anything. They have got to be an ordered pair for it to work. So it's infinite solutions. Now, there may be a case where you work all that out and you get something like that. You get something like 0 equals 3. If you get that, you would ask yourself, does 0 equal 3? Hopefully yourself will say, no, it doesn't. That's what no solution looks like. And we'll see some of those tomorrow. All right, it wasn't too bad. Hope you got it. We'll work on it tomorrow as usual. See you then.